Just wanted to give you my take on a pretty cool video I showed in class on resonance. Here's resonance in 2 dimensions, and what they've done is they put speakers underneath this table of sorts, and they put rice, and for certain frequencies you'll get pretty cool patterns that set up. So you can see sort of like that. And what I want to show you is that this actually has harmonics, kind of like what we've talked about in class. And the way we can analyze this is using, we have a Vernier probe, a pressure sensor probe, although you might be able to do it using a program like Audacity. And what we're going to do is we're going to measure the frequency. So get to the point in the video where you want to see it. In this case, we'll do it right about 16, 17 seconds works well. And I'll hit start, and then in the 0.03 seconds to take the data. What I have this set up for in the experiment, or rather the experiment, the data collection, I have it set at 50,000 samples per second, so it's going to be really good for measuring the frequency. The easiest way to get the frequency is to highlight the data and count the peaks. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, too bad 10 didn't fit. Usually you can get 10 in with the higher frequencies. Divide, and what you're dividing is, if you look down here, it actually gives you the delta t, the time represented by the area you've highlighted. So if you take that, divide by the number of peaks you included, that'll give you your frequency. Let me just show you really quickly what it looks like for a higher frequency. Say if I go up to 51 seconds or so, there's a pretty good one. So I'll go a little bit before. I'll hit start, and then I'll hit collect again. I'll pause so that people don't hate me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you divide that delta t to get the period. Now, I did this for a bunch of the harmonics, and I put it in this table so you can see where it is in the video time-wise, what the period was when I counted 10 waves divided by 10, the frequency, which is 1 over frequency, and I couldn't get a fundamental harmonic on the video, at least not a clean one. So what I did is I assumed that the fundamental harmonic is half of the second harmonic, which is what I presume I got with the first set of data. And the interesting thing is, when you look at these, you actually get pretty clean multiples. So these are the actual times I got when I divided by 10. Flipping them, or 1 over that, I got these frequencies, and where this harmonic number comes from is I just divide the frequency by what I presume the fundamental harmonic is, the fundamental frequency, and you get these clean numbers. They do a good job of going slowly through the harmonics in the beginning, and then it just goes up too quickly to keep up with, and they skip harmonics. But just for fun, by the time you get to 1:51, almost near the end of the video, I'm getting almost 5,000 hertz, which is the 29th harmonic. No matter what, it looks really cool, and I just wanted to show you that there is a connection between this and the harmonics we talk about in class, which are really only in the 1 dimension. I hope you found this as enjoyable as I did.